Hey there, curious minds. Have you ever wondered if there's more to our universe than meets the eye? What if I told you that scientists are discovering new dimensions beyond the four we're familiar with? Imagine a reality where dark matter isn't just a mystery, but a window into hidden worlds. Sounds unbelievable, right? Well, buckle up because today, we're diving into the groundbreaking findings that could change everything we thought we knew about the universe. Could there be a fifth dimension, or maybe even 37? Let's explore these mind-bending discoveries together. A fifth dimension and dark matter. Imagine a world beyond what we can see, beyond the familiar three dimensions of space and one of time. Scientists have recently proposed the possibility of a fifth dimension, one that could explain the mysterious phenomenon we call dark matter. This is a bold theory, but it's gaining traction in the scientific community. Dark matter, which makes up about 85% of the universe's mass, is invisible to our instruments. Yet, its presence is undeniable because of how it affects the way galaxies move. Now, what if dark matter isn't just some invisible substance? What if it's actually the result of particles interacting in a hidden fifth dimension? This idea suggests that the familiar particles we know, such as electrons and quarks, could be moving through a higher dimensional space, one that we can't perceive with our traditional tools. Imagine a wormhole or portal, allowing particles to travel between dimensions, which explains why we can't directly see them. The existence of this dimension could revolutionize our understanding of physics, helping us finally understand the cosmos's most enigmatic components. Think about it. If dark matter is merely a doorway between dimensions, then perhaps the universe is far more complex than we've ever imagined. What if there are hidden worlds out there, just beyond our reach, and we're on the verge of discovering them? The boundaries of our universe might be far broader than we think, and we could soon be exploring a new dimension in ways we never thought possible. What do you think? Could a fifth dimension be real? Manipulating time. What if I told you that scientists have found a way to manipulate time itself? Yes, you heard that right. Time as a dimension might now be within our control. Cutting-edge advancements in photonics have led researchers to explore a unique fourth dimension, not space, but time. Through precision technology, scientists are now able to change the way light behaves in a time-altered environment. This discovery isn't just mind-blowing, it's revolutionary. For decades, we've relied on light's speed to carry information. But what if the speed of light itself could be manipulated by altering time? This new development could lead to faster data transmission and advanced computing capabilities. Imagine the impact on everything from communications technology to artificial intelligence, innovations that would have seemed impossible just a few years ago. Scientists have managed to harness light's temporal properties, controlling its path and speed over time, allowing it to exist in a form we've never seen before. In a world where time seems fixed, this breakthrough feels like stepping into the realm of science fiction. But the implications are real. If we can control the flow of time through light, it might not be long before we see entirely new technologies emerge, affecting how we communicate, compute, and even perceive reality. Are we on the verge of seeing time manipulated for real? Four-dimensional crystals. Now imagine crystals that defy our understanding of the physical world. Quasi-crystals, a fascinating class of material, have just shown us a glimpse into the fourth dimension. These materials don't follow the simple, repetitive patterns we associate with traditional crystals. Instead, they display a kind of periodicity that goes beyond the three-dimensional world we know, hinting that there might be a higher dimension hidden in plain sight. In these crystals, atoms are arranged in a complex, higher-dimensional pattern that we previously thought impossible. They don't just repeat at regular intervals like most crystals. They have an arrangement that resembles a four-dimensional lattice. This discovery has profound implications because it shows us that nature can manifest complexity in ways we haven't fully understood yet. These quasi-crystals challenge everything we knew about symmetry and structure in the material world. They suggest that the way atoms and molecules interact might not be limited to the three dimensions we experience. Scientists have been uncovering the secrets of these strange materials, and the results are shaking up the world of solid-state physics. By studying these quasi-crystals, researchers are beginning to question the very nature of reality. What if these materials aren't just quirky exceptions? What if they're the key to unlocking new technologies or even new laws of physics? These quasi-crystals might just be the first tangible proof that there's more to our world than what we can see. Could they be the first step toward discovering hidden dimensions all around us? Lisa Randall and the higher dimensional universe. Have you ever wondered why gravity is so much weaker than the other fundamental forces of nature? It's a question that has puzzled scientists for centuries, but theoretical physicist Lisa Randall may have cracked the code. Her work in the field of extra dimensions suggests that gravity's weakness could be explained by the possibility of our universe existing on a three-dimensional membrane embedded in a higher dimensional space. Imagine our universe is like a flat sheet floating in a multi-dimensional sea. If gravity is leaking into these extra dimensions, it could explain why it seems so much weaker compared to electromagnetic forces or the strong nuclear force. This idea opens up a new way of thinking about higher dimensions, that they could be hidden in plain sight, affecting our reality in subtle, unnoticed ways. Randall's groundbreaking work has forced us to rethink everything we know about space, time, and gravity. By studying the behavior of particles at extremely high energies, she's laid the groundwork for understanding how the universe might be constructed on a deeper, hidden level. Theoretical physics could be on the verge of a major breakthrough, as Randall's work could provide a new framework to understand the fundamental forces of nature. Could this be the key to finally explaining gravity's mysterious weakness? If higher dimensions are indeed real, we might just be on the brink of uncovering the next great frontier of science. What do you think? Could extra dimensions be the secret to unlocking the mysteries of the universe? The future of physics could hold answers we never thought possible. The astonishing discovery of 37 dimensions. What if our understanding of quantum mechanics was about to be turned upside down? Imagine a world where particles exist in 37 dimensions, not just the three we can see, but dozens of others we never knew existed. This mind-bending revelation could be the key to unlocking quantum computing at an unprecedented level. Recently, scientists have made a discovery that challenges everything we thought we knew about the quantum world. In a groundbreaking experiment, researchers have managed to produce photons, the fundamental particles of light, that exist in 37 dimensions. Now, what does this mean for us? Simply put, photons, which we've always thought of as existing in our familiar spacetime, are capable of existing in a far more complex, multidimensional reality. This discovery opens the door to next-generation technologies, particularly in quantum computing and communication. Imagine the possibilities if we could manipulate photons in these 37 dimensions. The processing power could be limitless, allowing computers to perform calculations that are currently beyond our wildest dreams. Quantum computing could accelerate research in artificial intelligence, cryptography, and even medicine by orders of magnitude. With 37 dimensions at play, it's not just about faster computers, it's about building a completely new paradigm of computing that could change the world. This breakthrough also pushes the boundaries of what we thought was possible in physics, forcing us to ask, what else could be out there in these other dimensions? What if there are entire new worlds of information waiting to be explored, just beyond our current reach? This discovery might be the beginning of a whole new era in science, where our understanding of reality is expanded in ways we've only dreamed about. Could this truly be the future of computing and technology? Quantum computing and parallel universes. Imagine a chip so powerful that it could prove the existence of parallel universes. Yes, you heard that right. Google's development of the Willow quantum chip has shaken the world of physics, suggesting that the bizarre, mind-bending principles of quantum mechanics might actually be linked to the possibility of multiverses. This chip, which operates at the cutting edge of quantum computing, is capable of solving complex problems that classical computers can't even begin to approach. But here's the twist. As scientists delve deeper into the chip's capabilities, they're discovering something even stranger. The quantum state of the Willow chip suggests that the computations it performs may be happening across multiple realities, or parallel universes. The quantum nature of the chip allows it to explore all possible outcomes simultaneously, in a way that classical computers never could. This might sound like science fiction, but the more researchers study the chip, the more they realize that it could be giving us a glimpse into other dimensions of reality. What does this mean for us? If quantum computing is indeed tapping into multiple realities, it could have massive implications not just for technology, but for our understanding of the universe. Parallel universes have been a theoretical concept for years, but the Willow chip could offer evidence that they might actually exist. We could be living in a multiverse, where different versions of ourselves are living out parallel lives in alternate dimensions. This idea raises even more exciting questions. Could quantum computing allow us to travel between these realities? Could we communicate with alternate versions of ourselves? The possibilities are limitless. The development of the Willow chip could mark a new chapter in the story of quantum physics. One that not only redefines how we think about computing, but could also prove that the reality we know is only one version of something much, much larger. Could parallel universes really be out there, waiting to be discovered? That's all for today, explorers. What do you think? Are we really on the verge of discovering new dimensions? Drop your thoughts in the comments below, and don't forget to hit that like button if you enjoyed this mind-bending journey with us. If you haven't already, make sure to subscribe to Space Facts for more exciting discoveries about the future of science and technology. Thanks for watching, and we'll see you in the next adventure. Have you ever wondered how the universe will end? What will happen to Earth, to the stars, and to everything we know? Imagine watching time unfold at a breathtaking speed, from the rise of civilizations to the ultimate fate of everything. What does the future hold for us, and for the universe itself? Time-lapse of the future. A journey to the end of time takes us on an extraordinary ride, offering a glimpse into a future that is both awe-inspiring and a little unsettling. Are you ready to explore the mysteries of time? Let's dive in and find out together. Journey to the end of time. Have you ever wondered what the future holds? Not just the near future, but the distant, unfathomable future of the entire universe? Imagine if we could compress billions of years into just a few minutes. That's exactly what time-lapse of the future, a journey to the end of time, does. This isn't just a time-lapse of Earth or our solar system, it's a cosmic odyssey that takes us from the present day all the way to the ultimate fate of the universe. Created by John Boswell, this 29-minute film offers a breathtaking exploration of what's to come as time unfolds, both for our planet and for the universe at large. As the future speeds by in a few short minutes, we're given a front-row seat to the wonders and the mysteries that await us. From human achievements to the most extreme cosmic events, this film pushes the boundaries of what we think we know about time and existence. You'll experience the rise and fall of civilizations, the birth and death of stars, and the transformation of entire planets, all happening at once in a stunning visual representation. The film opens in the year 2019, introducing us to the Anthropocene, a new geological age defined by human impact on the planet. But this is just the beginning. What happens next is both awe-inspiring and sobering. The film takes us on an incredible journey, showing us how the world changes faster than we can ever imagine. And ultimately, how everything, even the universe itself, will meet its end. It's a thought-provoking ride that leaves you contemplating your place in the vast, ever-moving river of time. And the best part? It's not just a journey of the mind, it's a visual experience you won't forget. The Anthropocene and human milestones. The future isn't just about what happens to the universe, it's also about what we, as humanity, will achieve along the way. Time-lapse of the future begins by placing us at the dawn of the Anthropocene era. The world we know today is shaped by human progress, and while it's easy to focus on the challenges we face, this film reminds us of our potential. The Anthropocene marks the point in time when human activity began having a profound and lasting effect on the Earth, everything from the construction of cities to the rise of new technologies. As we move through the future, we witness the incredible milestones humanity will achieve. Imagine this. Humanity has finally set foot on Mars, opening the door for interplanetary travel and establishing our presence on another world. This isn't science fiction anymore, it's a possibility within reach, and that's just the beginning. The film zooms in on our future space explorations, including the possibility of human settlements beyond Earth. What will it be like to live on Mars? How will we adapt to the harsh realities of space, and what role will technology play in our survival? But the journey doesn't stop there. It's not just about getting to Mars. The future is filled with even more ambitious plans, from harnessing the power of renewable energy on a global scale, to potentially even altering Earth's environment to make it more hospitable for future generations. With every milestone, humanity takes a step closer to becoming a true spacefaring species. As the years pass in this fast-forwarded timeline, we see Earth transform in ways we can only dream of today. It's a future that inspires us to think bigger and bolder about the path ahead. Cosmic events and Earth's transformation. As the future unfolds, Earth undergoes monumental changes, But it's not just human progress that takes center stage. It's the unpredictable and sometimes violent forces of nature that shape the planet. Imagine watching as Earth evolves over millions of years, transforming before our very eyes. In this section of the time-lapse, the film highlights the dramatic events that will change our world forever, many of which seem almost too extraordinary to believe. First, we witness the return of the famous comet Hale-Bopp in 3357. Its presence in our sky would be nothing short of awe-inspiring, a cosmic reminder of the vastness of space. But that's just the beginning. Over time, Earth's environment begins to shift in radical ways. Sea levels rise, submerging vast portions of the planet's coastlines, and the Earth's surface starts to look vastly different from anything we recognize today. Imagine cities swallowed by the rising tides, leaving behind only the memory of a once thriving civilization. But there's more. In the year 5360, an asteroid impacts Earth, triggering a global catastrophe. It's a stark reminder that no matter how advanced we become, the forces of nature remain unpredictable and powerful. As the film continues to move forward, the Sahara Desert, once an arid wasteland, transforms into a lush, tropical landscape, showing how climate and geography can change in the blink of an eye. As the years press on, humanity might not be the only intelligent species we encounter. In 4226, the Voyager 1 spacecraft passes by the star Gliese 445, which is expected to be one of the nearest stars to Earth. Could there be alien life forms beyond our understanding? This section of the time-lapse reminds us of the fleeting, fragile nature of our world, and how everything, every creature, every city, could be erased by forces much greater than ourselves. The death of the sun and the end of life. The inevitable truth is that no matter how much we achieve as a species, no matter how far we venture into space, the end of life as we know it is written in the stars. Fast forward to over 2.9 billion years in the future, and the Earth we know is no longer recognizable. The sun, which has sustained life for eons, begins its final transformation. Its increasing luminosity marks the death of all plant life, a harbinger of the slow, relentless extinction of everything dependent on the sun's energy. The oceans, once teeming with life, slowly evaporate and Earth's atmosphere becomes increasingly hostile. The temperature rises to unbearable levels, making it impossible for life to survive. As the sun continues to expand into a red giant, it engulfs the Earth, turning our once vibrant planet into a lifeless, scorched rock. It's a poignant moment in the time-lapse, one that forces us to reflect on our place in the universe. Yet as heartbreaking as this destruction seems, it is merely the beginning of a much grander cosmic evolution. As Earth is consumed by the sun's final stages, our star becomes a white dwarf, its once blazing heat reduced to a faint cold glow. It's the ultimate reminder of the impermanence of everything, even the stars that have guided us through the darkest nights. This segment in the time-lapse doesn't just show us the death of a planet, it challenges us to think about our own legacy in the grand scheme of the universe. What will remain when humanity is gone? What mark will we leave, if any, on the universe as time marches relentlessly forward? The degenerate era and black hole dominance. As the universe continues its journey through time, it enters a period of profound transformation. Welcome to the degenerate era, a future where the stars, once burning bright with energy, have exhausted their fuel and faded into the cold darkness of space. It's a universe populated by the remnants of stars, white dwarfs, neutron stars, and the towering, mysterious black holes that dominate the cosmos. These dead remnants continue to drift through the void, their existence marked by the slow ticking of time, a stark contrast to the vibrant explosions and glowing nebulae we see today. In this era, gravity becomes the universe's most powerful force. With most of the stars having burned out, the universe grows darker, quieter, and colder. The once glorious spiral galaxies we recognize today are no longer filled with the radiant light of stars. Instead, they're populated by these invisible giants, black holes, absorbing all matter that comes near, growing ever larger with each passing century. Entire star systems are swallowed up, never to be seen again, as the universe slowly empties. This era is a chilling reminder of the universe's eventual entropy. The once luminous galaxies and nebulae that filled the night sky are replaced by the crushing silence of space, where the only sign of life is the slow, inevitable death of the stars. It's an era where time seems to stand still, and life, as we know it, seems like a fleeting memory in the vast, unchanging expanse of space. The degenerate era asks us to confront a harsh reality. In the grand scheme of things, our existence is but a brief moment, a tiny spark in the dark void of eternity. The black hole era and proton decay. As the degenerate era fades, we enter the black hole era, a time where the universe is defined by the influence of its most enigmatic and powerful objects, black holes. These cosmic giants, which are already a dominant force in the universe, begin to completely shape the destiny of all matter. Over time, the black holes grow even larger, their immense gravity warping space-time itself, pulling everything in their path into their all-consuming depths. But this isn't the end. Even these mighty black holes eventually face their own end. In a mind-boggling twist, the universe's matter begins to disintegrate. Protons, the building blocks of atoms, start to decay, turning the universe into an even more barren place. It's almost as though everything that once defined the universe, the stars, the galaxies, the very atoms, slowly unravels at the seams. The film imagines a universe where matter no longer behaves as it once did, where even the most basic building blocks are no longer stable. This process of proton decay leads to the disintegration of everything, as atoms break apart and the universe becomes a giant sea of radiation. In the black hole era, the universe is no longer the lively, dynamic place we know. Instead, it's a cold, lonely expanse, dominated by the power of black holes and the gradual decay of all matter. As stars and galaxies fade away and even the basic structure of atoms dissolves, time itself becomes meaningless. What remains? Just a vast emptiness where the only thing left is the lingering presence of black holes, reminders of the cosmic events that once filled the universe with light and energy. The end of the universe and the arrow of time. And so we reach the end of the universe, a final chapter that is as inevitable as it is awe-inspiring. The universe, once filled with stars, galaxies, and the potential for life, slowly fades into an unimaginable void. The last black hole, having consumed everything it could, begins to evaporate, a process known as Hawking radiation. This marks the final moments of the universe's existence as we understand it. The fabric of reality itself begins to unravel, and all that's left is the ultimate fate of everything, a dark, cold, lifeless void. But even in this end, there is a sense of profound beauty and mystery. As the universe reaches absolute zero, time itself ceases to have meaning. The film takes us on a journey through this cold, silent expanse, asking us to reflect on what it means for time to end. It's a haunting thought, yet an essential one. The arrow of time, which once moved in a clear direction from past to present to future, reaches its final destination. The film concludes with a powerful meditation on time itself. Brian Cox's narration reflects on the fleeting nature of existence, urging us to appreciate the present moment. The universe may be dying, but our consciousness, our awareness of time, is alive. In these final moments, we are reminded that even in the face of absolute destruction, there is value in our brief shining moment of existence. This ending is as much a philosophical statement as it is a cosmic one. It forces us to confront the ultimate question: what will we leave behind when time itself expires? In a universe where everything eventually fades away, the question of meaning becomes all the more pressing. The universe may end, but our understanding of it, and our connection to it, remains as the final spark of life in the vast, endless dark. And there you have it, an incredible journey through the future of the universe. From the rise of humanity to the unimaginable end of time, we've explored the mysteries of space like never before. What did you think? How do you imagine the future unfolding? Drop your thoughts in the comments below. We'd love to hear from you. If you enjoyed this mind-blowing ride through time, don't forget to like, share, and subscribe to Space Facts for more incredible content about the wonders of the cosmos. Until next time, keep looking up, there's so much more to discover. Have you ever wondered why Pluto, once considered the 9th planet in our solar system, is no longer classified as one? In 2006, the astronomical world was rocked when Pluto was demoted to a dwarf planet, leaving many people asking, why? Was this decision right, or was Pluto unfairly stripped of its title? In today's video, we're diving into the heated debate that surrounds Pluto's reclassification. Do you think Pluto should still be a planet, or do you agree with its new status? Let us know what you think in the comments below. The Pluto we thought we knew. Pluto, once the 9th and final planet in our solar system, was a beloved celestial body for generations. It had its own little spot in our childhood imaginations, alongside Earth, Mars, and Jupiter. It was small, distant, and shrouded in mystery. But it was a planet, no doubt about it, right? However, in 2006 everything changed. Pluto was suddenly stripped of its planetary title and the world collectively gasped. How could this be? Wasn't Pluto always a planet? To answer this, we need to go back in time to when this all started. For decades, Pluto's status as a planet was mostly accepted without question. It was only when astronomers discovered more objects in the distant reaches of our solar system, objects similar to Pluto, that the debate began to heat up. Suddenly, the old definitions of a planet didn't seem to fit, and thus, Pluto's future was placed into the hands of the International Astronomical Union. The question on everyone's mind was simple: is Pluto still a planet or not? This debate quickly became one of the most talked about events in the scientific community, and it sparked passionate reactions from both scientists and the public alike. But what did the IAU decide, and why did it lead to Pluto's demotion? In this video, we'll explore why Pluto is no longer considered a planet, the reasoning behind that decision, and whether it could ever return to its former status. Trust me, this is a fascinating story, and by the end, you might just see Pluto in a whole new light. The IAU's defining moment. In 2006, the IAU made a landmark decision that would change the way we view Pluto forever. The organization introduced a new, formal definition of what makes a planet. For something to be considered a planet, it had to meet three key criteria. First, it must orbit the sun. Second, it must be nearly round in shape, a result of its gravity pulling it into a spherical form. And third, it must have cleared the neighborhood around its orbit. Basically, it must have enough gravitational influence to either absorb or fling away any other objects in its path. Pluto checked off the first two boxes without a hitch. It orbits the sun and is spherical in shape, but it was the third criterion, the one about clearing its orbit, that tripped Pluto up. You see, Pluto's orbit crosses paths with that of Neptune, and there are other objects in the Kuiper belt, a region beyond Neptune, that share Pluto's orbital space. As a result, Pluto didn't meet the third requirement of the new planetary definition. This was a hard pill to swallow for many people. After all, Pluto had been part of our solar system's family for decades. How could it not be a planet? But the IAU was firm in its decision. Pluto's failure to meet all three criteria meant that it no longer qualified as a planet, and instead, it was reclassified as a dwarf planet. This decision would forever change how we categorize celestial bodies in our solar system, and it launched a wave of debate that still continues to this day. The discovery of Eris. Before Pluto's demotion, our understanding of planets seemed pretty clear-cut. That is, until astronomer Mike Brown and his team discovered Eris in 2005. Eris is a dwarf planet located in the farthest reaches of our solar system, and it's about the same size, if not slightly larger than Pluto. This discovery immediately raised a lot of eyebrows and sparked a major question. If Pluto is a planet, then should Eris be one too? Eris is part of a group of objects called the trans-Neptunian objects, which are located beyond Neptune. Pluto is also part of this group, but it had always been the only one that was classified as a planet. The discovery of Eris, however, threw a wrench in that classification. If Pluto was a planet, then surely Eris deserved the same recognition. But the problem was that there were many other objects in the same region of space, similar to both Pluto and Eris, and it didn't seem reasonable to call them all planets. This revelation led the IAU to reassess how they defined a planet. In the end, they adopted the now famous definition that a planet must have cleared its orbit, meaning it should be the dominant object in its region of space. Since neither Pluto nor Eris could meet this criterion, they were both classified as dwarf planets. The discovery of Eris, in many ways, forced the scientific community to reconsider the very idea of what it meant to be a planet, and Pluto became the unfortunate casualty of that reconsideration. Public outcry and emotional backlash. When the news hit that Pluto was no longer a planet, it didn't just stir up the scientific community, it created a full-on cultural uproar. For many, Pluto had been a steadfast part of the solar system, and the idea that it was suddenly demoted felt like a betrayal. People from young schoolchildren to adults were devastated. The public simply wasn't ready to say goodbye to Pluto as a planet. Children in particular were upset. For years they had learned in school that Pluto was the 9th planet. Now, they were being told it wasn't a planet anymore. Astronomer Neil deGrasse Tyson, who was one of the most vocal figures in the debate, received angry letters from kids expressing their heartbreak over Pluto's demotion. Some even wrote messages calling for Pluto to be reinstated as a planet. The controversy over Pluto's status quickly became a topic of conversation at dinner tables, schools, and social gatherings. It wasn't just science, it was emotional for a lot of people. The emotional backlash wasn't limited to children. Adults, too, expressed their displeasure, often feeling that the IAU's decision was too harsh. Some believed Pluto had been an important part of the solar system for so long that it deserved to keep its planetary title, no matter what the technical definition said. The public outcry over Pluto's reclassification highlighted just how attached we can become to the things we've known and loved, even in science. Pluto wasn't just a planet, it was a symbol of our curiosity and wonder about the universe. For many, saying goodbye to Pluto felt like losing an old friend. Scientific debate. Despite the IAU's decision, not everyone was convinced it was the right call. Many scientists and astronomers questioned whether the new definition of a planet was too rigid. They argued that the IAU's definition failed to take into account important features of celestial bodies like Pluto, which has its own moons, a complex atmosphere, and even signs of active geology. Pluto isn't just a small rock floating around, it's a fascinating world, complete with a rich history and mysteries still waiting to be uncovered. Some scientists feel that the IAU's criteria for a planet should consider more than just whether a body has cleared its orbit. Shouldn't the planet's ability to sustain features like an atmosphere, weather patterns, or even geological activity be important? After all, Pluto's moons, including Charon, show evidence of tectonic activity, and its surface has been found to be much more dynamic than once thought. For many, Pluto's small size or its position in the outer solar system doesn't diminish its planetary qualities. One of the key figures in the debate is planetary scientist Alan Stern, who led NASA's New Horizons mission to Pluto. Stern and many others believe that Pluto deserves to be called a planet because it has so much more to offer than many of the other planets in our solar system. As Stern famously put it, a planet is a planet no matter where it is. And in many ways, this perspective calls for a broader, more inclusive definition of what constitutes a planet, one that focuses on the characteristics that make a world unique, rather than how much it clears its orbital path. The scientific community remains divided, with some advocating for Pluto's reinstatement, while others stand firm in the IAU's decision. This debate continues to fuel discussions about the nature of planets, and whether our understanding of the solar system is truly complete or still evolving. Pluto's enduring legacy. Even though Pluto's planetary status was stripped away, its legacy is far from fading into the cosmic void. In fact, Pluto continues to capture the public's imagination in ways few other celestial bodies can. Pluto might not be a planet, but it remains one of the most studied and beloved objects in our solar system. In 2015, NASA's New Horizons mission made history by sending back the first close-up images of Pluto, revealing a world of stunning complexity and beauty. New Horizons unveiled Pluto's frozen mountains, vast plains, and intriguing surface features, some of which appear to be relatively young in geological terms. The spacecraft's flyby also captured incredible details of Pluto's thin atmosphere and its interaction with the solar wind. These discoveries shattered our previous misconceptions of Pluto as a cold, lifeless rock. Instead, scientists found a dynamic world, possibly even with underground oceans and the potential for future exploration. Pluto's legacy is also tied to the way it inspired generations of astronomers and scientists. Whether it was the debates over its classification or the fascination with its enigmatic features, Pluto has sparked a passion for discovery. It's encouraged curiosity, inspired space exploration, and reminded us how much we still don't know about the universe. While Pluto may no longer hold the title of planet, it's certainly left an indelible mark on both scientific research and our collective cultural consciousness. The ongoing debate. So where does that leave us? Despite its reclassification, Pluto remains an important and controversial figure in the astronomical world. The debate over whether Pluto should be considered a planet continues to this day, and it's unlikely to be settled anytime soon. Some scientists are still fighting for Pluto to regain its planetary title, while others argue that the current definition is a step forward in our understanding of the solar system. But no matter what happens with Pluto's classification, it's clear that the conversation surrounding this little dwarf planet is far from over. Pluto has sparked a fundamental question in science. How do we define a planet? And more importantly, can our definitions evolve with new discoveries? As technology advances, our understanding of the cosmos continues to grow. Perhaps one day Pluto might be reinstated as a planet, Or maybe we'll come up with an entirely new classification system that changes how we view the solar system. But until then, Pluto will remain an enduring symbol of how science is constantly evolving, always challenging our assumptions and pushing the boundaries of knowledge. What do you think? Should Pluto be a planet again, or does the current definition make sense? Drop your thoughts in the comments below and let's continue this fascinating debate together. After all, the debate about Pluto isn't just about one planet, it's about how we understand the universe. So what do you think? Should Pluto be a planet again, or is its new title here to stay? The debate continues, but one thing is certain: Pluto will always hold a special place in our hearts and in the history of space exploration. Thanks for watching. And if you love discovering the secrets of the universe, don't forget to like, subscribe to Space Facts, and hit the bell icon for more adventures.